Yeah, today I'll basically talk about the two new front-end frameworks. They're not that new, but they are gaining popularity recently. One is Stencil.js, the other one is Svelte.js. Okay, but first, still need to answer the question: why bothering looking at another framework? It starts like this. So I was reading some blog post, and it's written by Alex Russell, and he mentioned a term called interoperability. It's like a very alien word to me, and I just Google it. What does it mean? It means the ability of computer system or software to exchange and make use of information. Still not that clear. So just let me try to explain in layman terms. Let me ask you a question. Have you ever think of how can I use an Angular component in a React application? It was like possible for a while. I think, what? Why would I want to do that? Yeah. So it's something really we never thought of previously, right? And if we took another approach, that is why we don't. Because imagine one day, I don't know how long React will maintain its popularity, but maybe one day there could be a better new framework X, and we really want to move to that new framework. Does that mean we need to rewrite all our Shopee code using that framework? Isn't that too costly? This may be a bit too extreme, but you can imagine another case. We find an awesome component that is only available in this particular framework X. It's not available in React. What can you do nowadays? You can only read the code and maybe port that to React. Right? And that's exactly what happened. To take Bootstrap as one example. I think everyone here knows Bootstrap. And you can find a React implementation of Bootstrap, an Angular one, maybe another Vue one. I'm not sure, but that's exactly what's happening in the community. Bootstrap is good. Everyone wants to use it, but we are stuck with this kind of fragmented framework, front-end framework. We have to re-implement the same thing over and over again, and this could be a bit of waste of our energy. Yeah, so that's go back to the interoperability. Why not? Why we cannot use another Angular component in our React framework? The reason is simple. Different frameworks, they have really different understanding or opinion on the state management. For example, in React, you have the single data flow, you have your props, state, and Angular Vue, they have a slightly different lifecycle. It's not hugely different, but slightly different. And it seems each one has a different opinion on how they should write the CSS in JS. So is it possible to have a gold standard or a common consensus of how those things should be? Then all the framework just adopt those standards. Then hopefully we might have a way to, like a meta framework that encapsulate all those kind of variations or logics. Is that possible? I don't know, maybe possible, but people will debate to the death, I guess. Just think about one-way data flow and double data binding. Which one you like? Then people just keep debating it. It might never comes to an end. So why not we just look for something more practical? Can we have two frameworks in one application and they just live side by side? Is that possible? Theoretically, it seems yes, but the answer is no. And the biggest issue is this what we call framework runtime. That means the bare minimum code you must ship to any client before you can render any line of code onto the screen. So to this chart as a comparison. So this is, I think, 2018. So imagine your application use both Angular and React, of course, plus Redux. Angular alone will cost you around 300 kilobytes, and plus React costs you another 200 kilobytes. That means before user can see anything, they will need to download 500 kilobytes of code, download and parse and execute by the browser before user can see anything. That essentially means that there's actually no way or little room for the front-end developer to deliver a fast or smooth web experience with two huge framework runtime at the same time. Yeah. That's why this caught me attention. So I noticed this new trend in the community. It's a topic called a framework as compiler. Sounds like a lot of buzzword. So first is Stencil. It's all copied from their website. Stencil is a compiler that generates web components. Okay, and there's another one, Svelte. Svelte compiles your code to tiny framework-less vanilla.js code. So there's all this shiny buzzword, the compile. Wow, we have a compiler in front-end nowadays. So that's really intrigues me. What do they mean by compile, and how do they actually make it happen? Yeah. So I decided to check it out. But spoiler alert, framework-less compiler, they are just buzzword. It simply means that the runtime is so tiny, it's actually possible to bundle or inline those framework runtime within your component code. Okay, so let's just dive into it. So I decided to do a simple experiment. So I create a very basic React application, and I will run two to-do MVC built with Stencil and Svelte. So that's like a three framework in one application. So how will that work out? So this is like the basic setup. I have my React app and has two node modules. Of course, first I have your Stencil to do MVC, and another one is Svelte to do MVC. Okay, so demo time. It's very ugly, so bear with me. I don't have time to polish the UI. But the thing is that this is a React application, and I have two to do MVCs. This part is entirely handled by Stencil, and this part is entirely handled by Svelte. And to make things a bit interesting, that I decided to do some message passing. So all the message is actually coming from React. I pass some message from React framework to these two frameworks, so hi Stencil and hi Svelte. And you can do some typical to do MVC stuff, to do 1, to do 2, and you can mark it, unmark it, and delete it, etc. So I think same for the Svelte. So I will not just do more of them. It's just a pretty stupid to do MVC. But what's important here is that first you have to trust me that this is really rendered by two different frameworks. I can show you the code. So basically, just go to Stencil first. It says it compiled to web components. So what does that mean? How do I use a Stencil component in React? This is how you use it. So each component will have a loader, and I just import define custom element, passing in my own window. It is because it's a custom element. You see how I use a Stencil component? It's really interesting. I didn't import anything. I just I just render a tag or custom element that is to do MVC. It's just like a magic. I didn't import anything, and somehow it just works. This is because under the scene, each window has to define this particular custom tag with the actual implementation of to do MVC. Basically, that's what it means. It compiles to a web component. I have to register that web component. Once it's registered with the browser, you can just use it as any other built-in HTML element. Okay, so this is how we use it. And to give you a big proof that this is really rendered by Stencil, not a React. As you can see here, this is really an HTML tag inside your DOM, and all the extra elements are actually inside this shadow DOM. This is the shadow root, so it's a pure web component, basically. Yeah, just to double check again, it's really like this. Yeah, this is you actually have a to do MVC tag, and this is the message passing, and this is entirely the domain of Stencil. Okay, and so we know how to use it. So how it actually works. So let's look at the files inside this Stencil to the MVC. There are a bunch of files, but I'll just mention the most important ones. We got a loader. The loader is like 300 bytes. We got a runtime. The runtime is around 30 kilobytes. And of course, we need our actual to do MVC implementation, which is just 1.6 kilobyte. It goes to be small because it's just such a simple to do MVC. Okay, so I'll explain the files one by one. Loader, what does loader do? Loader is pretty much like a Webpack manifest. It contains nothing but basically the module information, the module ID, module name, and so that the actual Bootstrap code knows where to look for those files. So it's just a meta information about all your code bundles. Simple. And this is my actual implementation of to-do MVC. I won't go through the code details now, I'll cover later, but as you can get a rough sense, this is pretty typical to-do MVC implementing in a class, so nothing fancy here. So what's inside the runtime? I think this is an interesting one. So what do we mean by you have a browser runtime? What's necessary to what's essential inside a runtime? This is what's essential for Stencil. It has a virtual DOM implementation. Yes, Stencil uses virtual DOM. It has its own implementation of a module loader. It got some logic to cover the lazy load because Stencil provides out-of-box code splitting and a lazy loading mechanism. And of course, it has a very thin layer to wrap your code and generate web components, something like that. So this is everything, yeah, literally everything inside the runtime.js. It's pretty impressive it can squeeze all those things into 30 kilobytes of code. So this is the runtime. So quick recap. Yeah, it ships everything, not only your production code, your business code, also ships the browser runtime, except it's kind of small, not that small, but impressive work. Okay, so next one, let's go to Svelte. How do we use a Svelte component in React? This is kind of less interesting. We will import this particular Svelte to MVC class here. Okay, and because this is not a web component, you cannot really render it directly. So the way I do it is that I attach only when my React element component is rendered. I got the reference, and then I'll pass this particular DOM reference as a target of my Svelte component, so it knows where to render the Svelte content into. And I can also do some simple message parsing by just passing in the message as a prompt. So pretty simple. It's just a class. You have to pass in all those things into the constructor. So nothing fancy. It looks pretty standard. It's not that interesting compared to Stencil. And this is final rendered HTML. Again, it doesn't render into Shadow DOM. It just renders into the HTML, and it's just a pretty standard DOM. So looks quite normal. So here, then this is the interesting part. I start to inspect the output of a Svelte component. Because Svelte doesn't provide code splitting at the moment yet officially, so it's just the output as one file. So the bundle file is 16 kilobytes in total. I counted the code is 560 lines of code. And then I'll count again. I count first my business logic, my to-do MVC. It actually has 260 lines of to-do MVC code, which translates to roughly 7 kilobytes. And this is the super impressive part. The runtime is only 300 lines of code and only 8 kilobytes. So this is the part you start to get a bit fishy. Because remember, our code size for the Stencil component for our to-do MVC is 1.6 kilobytes. And how can it be such a huge difference that my compiled Svelte to the MVC is so large? It's already 7 kilobytes. What's that extra, I don't know, maybe 400% more code. And what's the magic that how Svelte can have such a tiny runtime? This is really impressive. Only 300 lines of runtime. What's inside it? So let's dive into it. I didn't use the to-do MVC code because the generated code is too long, you will lost. So I choose another very simple example. So on the left is a Svelte component. It's just a simple timer, not timer, a counter, sorry. So initially the count starts from 0, and I have a button. Whenever I click on the button, I'll increase my count by 1. And I have a div just to display the number of count, and if count is equal to 1, I render something differently. So yeah, this is my setup, very easy to follow. And on the right-hand side is actually the compiled code. I comment out some code so that you can see the main structure. So this is in part nothing interesting. I have a function called create a fragment. I will explain later. I have another function called instance. So it seems like my handle click will become a method of this instance, and whenever I change something, I'll just invalidate this count. So seems quite okay. I mean, no extra code. This is what I've written, just maybe compiled in some other ways. And this is my application. So it tends the component, and it only has a constructor that init. So quite a tiny code, right? I mean, remember we have roughly 200 lines of code. Why this one is so small? Because most of the logic actually is inside this create a fragment function. This create a fragment function will be passed in as a parameter of the init function. And this create fragment function contains all the logic of initialize the DOM element, how to mount the component in the correct order, and when there's any value changes, how to only update that particular DOM UI part dynamically. I'll explain what do I mean by this. So let's just focus on the create fragment. Going back. So look at the top. Some variables. I got a div, I got a text node, I got another text node 2, text node 3, I got a button, I got something else. So this I try to make sense of this, okay? So I got a div, and since I got a text node, I got a button. It seems like this function is able to figure out how many DOM elements I need as variable, okay? So that's the first thing to remember. And I got a C function. So it seems like this is the part where all my variables got initialized. It's able to recognize the div should be a div element. The T0 is a text element with some value, and here is the button, etc. So this is a part, it needs the variables. And there's this M function. So this is even more impressive. So you remember, it seems like really it understands from my template how it should execute the instructions one by one so that I can get the final DOM. I have to insert my div into target first, and then I need to append the T0 into the div, then T1, T3, T2, T3 have to be in this order. After that, I insert something else, and I insert a button. So really that's like the render logic compiled to the instruction level, but only for this particular component. Yeah, this is the mount. I assume the M is the mount here. And here's the P function. That's the dynamic update part I mentioned. Whenever I change the count, it is able to figure out I only need to set a new count value into my T1 node. And of course, I have some customer logic. If count equal to 1, I have different text display. So I only need to update the T3 value with the T3 text node with the new value. So this is absolutely no virtual DOM. This is way faster than virtual DOM because anything you change, you know exactly which particular part of the DOM element you have to update, and only update for that. No more virtual DOM different. So this is just what they advertise for. And they got a bunch of more code. Yeah, so this is the moment kind of I understand, go back to my original stats, why my to-do MVC gets so large. It's definitely way larger than my original code because all of those kind of rendering, updating, initializing logic has to be compiled and inlined into my actual to-do MVC build component. And it still have a tiny runtime. But if you look at the function names of those runtime, it's more like I don't know, assembly instructions, very atomic, very tiny operations. It's more like a helper. It helps you to attach, append, initialize an element, and bind a listen, something like that. So pretty tiny. This is, I think, partly due to they don't have a complex virtual DOM implementation, just really inline all those DOM manipulation logics. Pretty magic and super impressive. So that's more like a quick anatomy of those frameworks and how it actually works under the hood. I think it still works for me to do a simple intro of the framework, how you actually, as an author, to use those authoring tools. First, how do I write my stencil to do MVC? I have my type. This is my to-do is to-do. I have the text as a string, or complete as a boolean, ID as a number. So then basically I have a state. My state is to-dos is an array of to-do, and I have a prop. It's a message and it's a string, and I have some intermediate state. The to-do text is basically the one user input in the input box. So wait, if I stop here, does this sounds very familiar to you? I have a prop, I have a state, and I have a component, and I declare my type here. And I have a bunch of class actions, and basically I just change my to-dos. And what's more, I have a render function, and I'm writing my JSX expressions inside this render function. So what does that mean? It's 90% like React. So when I start to learn Stencil, very little obstacle. And the authors admit that they really get a lot of inspirations from React. And for example, the thing behind the thing have the virtual DOM, and they also have the single data flow, etc. So I will not spend too much time on Stencil. I think you all know it if you know JS. Although it's pretty React.js, I know it's pretty interesting that a few things really caught me off the hook. For example, I was debugged a very nice debug that somehow my checkbox is not controlled. Until the moment I find out that no, there's no value. Once you set the type to checkbox, you should set checked instead of value. If you have been familiar with React for so long, it just uses value for everything, right? So this is like the moment you realize there are many things in React they have done for you, but it's not that easy, or it's not there actually. It's pretty interesting. That's the moment I caught me. Yeah, pretty interesting. Also, yeah, you don't have your own change. You only have own input. Remember? I forgot. So that's the moment I recall it. Yeah, we only have own input. Yeah, pretty interesting moment. But overall conclusion, not much difficulty to learn. Pretty similar to React. Next, let's look at the Svelte to MVC. This is a bit hard to digest already, so I'll try to be slow. First, on the high level, I have a script tag, I have a style tag, and I have my DOM structure. So the design resembles an HTML file. So you try to encapsulate all your styling, your JS, and HTML logic in one piece. So first impression, kind of good. Everything in one place. I think also close to the views methodology. Let's just go through the script part. Import to-dos from store. Interesting, store. We'll come back to the store later, but yes, the Svelte provides you a store implementation out of the box. So I use the store to implement my to-dos. And I have a new to-do. This new to-do is just for me to store the temporary input text when I'm adding new to-dos. Okay, so basically that's the way. You think, let me try to phrase in React terms. So this is your state. Anything you declare in the script that has a let is a state. Pretty simple. And when I use my new state, new to-do, sorry, I use it here. So it's not all the let variable is a state, but as long as you have your reactive binding, whenever your new to-do change, the UI will change automatically. So basically any variable plus a binding will behave similar to a state, I think. How to make a prop? Equally simple. If you export the let, then become a prop, because others can also set to the let, right? So that's how it makes. If you still you won't get your familiar concept, this is how you make a props. And whenever the variable changes, it will re-render. So this is purely reactive stuff. And how I use my to-dos, I think is also not that hard to understand. Although you will start to realize Node.js just the typical templating language. You have a few vocabularies for you to express your for loops, your if else, and you got a bunch of extra directives you must remember to bind, to do the event binding, etc. But overall, the logic, I think, definitely easy for you guys to follow. So yeah, that's like a very, very quick class for Svelte. But yeah, we have to explain store as well. I think this is also an interesting concept. Built-in Svelte provides you store. You have two types of stores. One is writable, one is readable, and it actually resembles the Redux store quite well. Except I like it more, I think, because basically you have your actions and your data at the same time. It has no concept of reducer. It's just here. You have only your action updates or manipulates the data directly. But it's in one piece. I feel it's better than reducer, actions, action creator, selectors, kind of scattered around so many different places. So this is the storyline. Again, I won't go through the detail, but yeah, they do have a story. All right. So let me try to do a quick recap. Stencil versus Svelte, and basically just repeat what I have said just now in a few categories. First, the renderer. So Stencil uses a virtual DOM implementation, meaning your render function only gives you a bunch of virtual DOM elements, and there's a runtime in behind translates to or mounts the elements into the actual DOM, and that's all the difference. Svelte, no, it doesn't have a virtual DOM at all, and the instructions are kind of compiled or inlined into your component code directly. So that's something totally new. Data management. Stencil has props, just need to use a decorator add props. Has state, just use another decorator called add state. In Svelte, they have something similar. Props, you just export let, and the state, you just use a let. Definitely, you have to combine with all this data binding or reactive statements so that it becomes kind of binded. Both of them provide some event pipeline, or if you are familiar with Vue.js, they call it a bus. So it's provided, and React doesn't provide it. Svelte has this writable or readable stores I just mentioned. So pause it for a while. So since Stencil kind of resembles React in so many places, you start wondering, okay, so where is my context, which is actually called a state tunnel in Stencil. Where's my Redux store? How do I use my Redux with Stencil if Stencil is so similar to React? The answer is that I saw their doc website, so they do have this entry, state tunnel and sys2do, and they do have the Redux integration and sys2do. So the functionality is definitely there, but the fact that they don't write a doc makes me a bit scary. Maybe they are going to make big changes, or they're also not quite sure how to do this kind of thing. I don't know, it's to do. Next, template languages. Stencil allows you to use JSX, offers you the full JS expressiveness, but definitely it's a lot harder to optimize any dynamic expressions in the JSX scope. Svelte offers you a more traditional templating languages. It's very limited in terms of vocabulary, and you have to remember a lot of custom directives to be able to efficiently use this framework. But the good side is that now we are able to, that's the whole reason why it's able to parse and compile your DOM structure and expressions into like a, sort of like instructions. Type support, Stencil provides you out-of-box TypeScript support. For Svelte, there's an issue open last year, August, and it's still open. TypeScript support, so you know what's happening. Yeah, now neither of them support float type, sorry. Yeah, next CSS. This one I think I might miss out, but Stencil, basically your CSS rule is rendered in the shadow DOM. That means it will be scoped by the browser naturally. There's no chance your CSS rule will include other part of the pages. It basically requires you to write CSS in separate files. Sorry, CSS in JS allows, but it basically provides you the full CSS expressiveness. And then when it comes to Svelte, it's pretty interesting. It also has scoped CSS, but the way it does is pretty simple. Basically, for any of your selectors, you will add another hash class, Svelte ID. So I'm not sure how will that affect performance, because essentially any single selector expression will have two, but it definitely works. So it's okay. It allows you to write the CSS in style block, so should have the similar or full CSS expressiveness. By expressiveness, I mean that you should be able to use all the newer languages like add keyframe, add animation, CSS animation, or the pseudo selectors or pseudo elements. You should be able to support them all. Okay. Next is code splitting. Stencil has built-in support for code splitting and lazy loading. It has this kind of sort of a zero configuration automatic way to make it happen. It's kind of nice, but downside is that I don't know how to tweak it. Yeah. Svelte, no official support at the moment yet. There's some third-party support, but yeah, no official support. Okay, so that's probably like a very quick comparison of these two frameworks. Some final thoughts. I have to go back to the original point. Is this really interoperable? Does that mean that now finally we can really use a component written for other frameworks in my framework? The answer is kind of, but there are many deeper problems remain unsolved for myself. Because you realize just now when I do the demo, the to-do MVC is sort of self-contained. My framework, my Svelte component, Stencil component, they have all the necessary, not only UI logic, but also data logic. It's just like a self-contained page or a feature. And of course, it will be very easy, easy to try to embed those into a React application. But there are a few problems I feel to me is unsolved. First, I call it how do we solve this cooperative rendering scheduling problem. For example, in terms of React, React is going to rolling out this async rendering. That means React will try to schedule your rendering, and any set state might not result in any UI changes synchronously. React will decide what's the right moment. But let's say you use React with Svelte. Svelte doesn't have this at all. It's purely reactive. You change any data, it will change immediately. So will this leave you an inconsistent UI state? Svelte part already changed, but React part didn't change until sometime later. Will that be annoying, and how do we solve it? I don't know. And lazy loading. So React has its own lazy loading mechanism, and Stencil also has its own lazy loading mechanism. How do we know which one loads first, and how do we guarantee one must be loaded after another one? And things like that, I don't know. I don't have answer for this yet. And more importantly is that different frameworks really have different lifecycle abstractions. So how do I compare one lifecycle event in another framework? And more importantly, React provides you this shoot component update, so you can actually preempt rendering. But there's no such thing in many other frameworks. That could lead you the case that your React, although the data changed, your React didn't re-render, but the other framework they had to re-render. So those are just the open problems that comes to my mind. Of course, the bigger problem still remains with the state management. Just now you see I didn't actually pass data around. I passed a very simple one, a simple message. But let's say I want to have two to-do MVCs that reads the same data from my React store. How do I do that? Actually, I tried and I feel actually it's not very easy. And especially when you have framework designed with different mindset. One only provides you one-way data flow, the other one provides you data bindings. How to keep all those data in sync between frameworks is very, very challenging. And yeah, so that's why I say kind of, because now with the runtime so tiny, yes, you can have all of them, but how to make them cooperate with each other, that's a deeper problem. Or it's actually a non-problem because it might not work out, so I'm not quite sure. So just what I like, what I don't like, in case people ask, since I talk about framework. Stencil, what I like the use of web components. I was really impressed that all I need to use that Stencil component is just to write that tag. It's very intuitive, and I feel it's like future. What I dislike, I don't. It's not that I don't like the virtual DOM. I don't like the React concept, but those are old things to me. I expect to see new things, but those are just things I already know. So that's the part I dislike. I feel they are a bit lazy. They copy too much from React, maybe. Svelte, what I like. I think the compiling UI logic into instructions is really mind blowing. This is the first time I have seen anything like this, and it's awesome job. So definitely we should keep attention on this kind of trend. What I dislike, many of the things is very opinionated. It might be hard to adopt. So that's a very quick summary. Yeah, so with that, I think that's the end of my talk. Yeah, that's all. Thank you.